Nothing like a sip of water. You know, we take it for granted, but maybe that's a mistake. And for sure, it's a mistake in regions where there's very little water, deserts, and even more so now that the population is growing by leaps and bounds, and in a time of climate change, when we don't know whether the deserts are going to get even drier or wetter, hopefully. Let's talk about water. In this lecture, we're going to talk about water resources that are shared between the United States and Mexico. So let's talk about the rivers of North America. There's 12 great rivers, and here on this map, you can see them. And the Rio Grande is one of these great rivers. It's the southernmost of the great rivers, and it's the fourth longest river in North America. And it forms a natural border for half of the border between the United States and Mexico. By the way, in Mexico, they don't call it the Rio Grande, they call it the Rio Bravo del Norte. So sometimes it's just Rio Bravo for short. All right, Rio Grande is more than 3,000 kilometers long. It begins way up here in the San Juan Mountains of southern Colorado, and then it flows south through New Mexico, the length of New Mexico, and then bends towards the sea, defining the border between Mexico and the United States here in Texas, before flowing out to the sea here between the twin cities of Brownsville, which we'll talk quite a bit about, and Matamoros. So it is an area that has been inhabited for a very long time. There's 24 UNESCO World Heritage Sites in the United States, and 3 of them are Native American sites in the northern Rio Grande drainage. Mesa Verde, which is ruins of the Anasazi peoples that inhabited that between the 6th and 12th centuries. The Pueblo of Taos, which has been inhabited since 850 AD and continues to be inhabited today. And then Chaco Culture Natural Historical Park in northwestern New Mexico. Okay, so the European experience in this region begins with Alonso Alvarez at the mouth of the Rio Grande in 1519. And he discovered the Rio Grande for the Europeans. And at that time, the river's mouth was more than 30 feet deep. And Alvarez was able to sail nearly 20 miles up the river without running out of room to tack his 4 ships. And as late as 1907, there were steamships that carried passengers and cargo 100 miles up the river, while the river cities like Brownsville and Matamoros were thriving ports. But now all that's left at the mouth of this river is a still and shallow lagoon of algae green water that stops pretty much several hundred yards from the ocean. So let's watch 50 seconds of a video about where the Rio Grande, Rio Bravo flow into the sea today.
Where the river meets the sea, just the way you are, forever may you be. Boca, boca chica, what else can I say? Just the way you are, forever may you stay.
I hope you enjoyed that short video. Okay, let's talk about rivers and rivals. So rivers, like other natural obstructions to land transportation, provide natural boundaries between nations. These include, besides rivers, mountains, deserts, lakes, and of course, oceans. And the bigger the obstacle, the bigger the separation of the people and their societies. Among the natural obstacles, rivers are the weakest separation. So the notion of rival is coming from the Latin word rivalas, which describes people living on opposite banks of a river. Now, rivers and deserts in particular often break down these boundaries because water is a scarce resource. So it draws people from the surrounding area into the region around the river. And so when you have competition for scarce resources, like water in the desert, this often leads to conflict. And the Rio Grande, Rio Bravo is such a river. All right, now, the first disagreement between the United States and Mexico about the Rio Grande had nothing to do with the water in it. It was where the river was. So we have to go back 170 years ago to when James K. Polk was elected president on a platform expanding the U.S. territory into Oregon and Texas. Texas was not a U.S. state then. He was elected, and in 1845, Texas was annexed as the 28th state. But the boundary between Texas and Mexico continued to be disputed, with Mexico claiming that the Nueces River was the boundary, and the U.S. said, no, it's the Rio Grande. And push came to shove, and Polk sent U.S. troops down to Brownsville to try and lure the Mexicans into starting a conflict, which they did. And so the Polk could argue for a declaration of war. So in April of 1845, Mexican forces attacked the U.S. forces in Brownsville, and the U.S. declared war. It went on until the Treaty of Guadalupe Hidalgo was signed in February of 1848. Now, we're going to come back to Brownsville because Brownsville was sort of where an interesting story in Latin American history, U.S. history starts. And it's also, there's a new chapter opening there now. So we'll come back to that at the end of this lecture. All right. The Rio Grande, Rio Bravo, it's got two names. Is it one river or two? Well, it is shared between the United States and Mexico, especially downstream. It does have two names. But interestingly enough, the evolution of the river system is such that it really didn't connect all the way from southern Colorado down to the Gulf of Mexico until a few 100,000 years ago. And again, today, the river does not flow uninterrupted to the sea. There's the upper Rio Grande, and there's the lower Rio Grande, which is the Rio Bravo. So we have this problem. Maybe we should rename the Rio Grande, Rio Bravo as the Rio Poco, which I think in Spanish means the small river, or the Rio Importante, which of course means the important river because of the water in it. All right, so let's talk a little bit about human history and the geologic evolution and hydrology of the upper Rio Grande, which is here. And then we're going to talk about water resources and the challenges that are facing, especially the lower Rio Grande between Mexico and Texas. So in order to understand these history, we need to understand that nations that share a river have treaties about how the water in that river is going to be used. And for the Rio Grande, it's even more complicated because the states, three of the states that use the upper Rio Grande water, Colorado and New Mexico and Texas, also have treaties within the United States. So there are interstate treaties, and then there are U.S.-Mexico treaties. So there are two important U.S.-Mexico treaties. One is in 1906, and the other is 1944. And these define how the waters of the Rio Grande, Rio Bravo should be shared between the two nations. The interstate compacts between these three states explain how the water needs to be shared between those three states. And then another one is the Pecos River Compact of 1948, which concerns the Pecos River, which is a tributary of the Rio Grande. And this compact concerns how the limited water of this river is shared between Texas and New Mexico. So the history of water conflict on the Rio Grande in the late 1800s and early 1900s. What happened with the migration of the Europeans westward from the United States into Colorado and New Mexico soon caused water shortages in the region. So in some of these southern Colorado valleys, irrigation increased by 600%, and that's going to cut down the water that comes down into New Mexico, and that caused all sorts of problems. And then as New Mexico uses more water, that causes problems down here. And so people started pointing fingers at each other, and Mexico accused Texas of bringing on the shortage, and Texas accused Mexico. And that triggered the negotiations that led to the 1906 U.S.-Mexico Treaty. And this treaty guaranteed Mexico at least 74 million cubic meters of water, or 60,000 acre-feet of Rio Grande water per year. So just for comparison, those of you that live in the Dallas area, White Rock Lake here contains about 18,000 acre-feet of water. So it's a few White Rock Lakes. All right, now another treaty between the United States and Mexico had to do with the water of the Conchos, which flows in from northern Mexico into the Rio Grande here. And this treaty said that the United States gets 1/3 of the flow of the water reaching the main channel of the Rio Grande, Rio Bravo, from this river system. And that requires that that third shall not be less than, as an average amount in cycles of 5 consecutive years, than 350,000 acre-feet annual. That's a good amount of water. And then there were some codicils about what happens when there's a drought, how it best to be made up. And this same treaty also specified that the U.S. should annually deliver 1.5 million acre-feet of Colorado River water to Mexico, and the Colorado River is over here. We're not going to talk about that, but this treaty covered both rivers. Both nations wanted both of the rivers to be dealt with in this treaty. All right, now this region is starting to grow very, very rapidly, and one of the big reasons for that is because of the maquiladoras. Okay, and so the history of that is in 1994, the U.S., Canada, and Mexico agreed to form a free trade zone, which meant there's no tariffs going for goods going back and forth. And this was called NAFTA. NAFTA was replaced in 2020 by the United States-Mexico-Canada agreement, which basically did the same thing. And as a result, Mexico is Texas's biggest trading partner, $123 billion worth of trade in 2021. Now, what has happened with NAFTA, USMCA, is that U.S. companies have built plants on the Mexican side of the border to assemble things, and then those things are brought back to the United States. So these assembly plants are called maquiladoras. There's over 320 of these factories in Ciudad Juarez alone today, compared with a third of that before NAFTA. And this creates jobs, population growth, environmental problems, and demand for water. So as people move into this region for good jobs, they're going to need more water. So let's talk a little bit about maquiladoras. These are factories in Mexico run by a foreign company exporting its products to the country of that company. So that's most of the United States. They're mainly located along the U.S.-Mexico border so that it's easy to move things back to the United States. So the deal is all the raw materials go to Mexico on a temporary basis, and they're used in the manufacturing and then shipped back to the United States. And because Texas borders several Mexican states, Texas is the main throughput for the flow of products from the maquiladoras into the the United States. And Ciudad Juarez is particularly important because this is where the Maquiladora model was built back in the 1960s and has been ever since the economic backbone of the border region. That those 320 plants that they have in Ciudad Juarez employ 1/3 workers. And basically 60% of the Maquiladora jobs in the state of Chihuahua are in Ciudad Juarez. So this is the El Paso Juarez borderplex. So here's Mexico, here's the United States, here's Juarez, here's El Paso, here's the Rio Grande. The Rio Grande makes it possible for people to live in this desert. You can see this is desert. This is the Chihuahua Desert. Here's looking a little bit closer at it. You can see how close El Paso and Juarez are. Here's the airport over here. Kind of turned a little bit on site because north is over this way like this. But you can see that these two cities are cheek and jowl by each other. All right. And this region is growing rapidly. So these are 4 census years, 1990, 2000, 2010, 2020. So El Paso's grown a fair amount, from about 500,000 to 2/3 And El Paso County has grown a little bit more. Ciudad Juarez has doubled in population. And so the entire region has doubled in population in those 40 years. It's really a very rapidly growing area, and that water demand is increasing with the population. And even below this, down the river, the entire lower Rio Grande Valley has experienced explosive growth in just about everything: population, industry, commerce, tourism, agriculture. The demand for water just keeps going up and up. And this is the center of the NAFTA USMCA driven border economy. This is an important part of both the United States and Mexico. And the critical thing is water in this region. All right, so let's talk a little bit about the geologic evolution and the hydrology, why the river flows where it does. So there is the Rio Grande, Rio Bravo Basin. It's about 500,000 square kilometers. This basin, shown here in brown, is about half in the United States and about half in Mexico. You can see the US part, you can see the Mexico part. Now, interestingly enough, this little town of Fort Quitman here, just below downstream from El Paso Juarez, separates the upper and lower Rio Grande basins. And today, there are basically 2 rivers. One of them flows from Colorado down to about here and basically is dried up, all used up. And the other one, because the Rio Concho starts here and flows all the way to the sea. So here we are going to the headwaters of the Rio Grande. So this is the Four Corners area: Utah, Arizona, Colorado, New Mexico. There's Taos, there's Santa Fe, there's Albuquerque. This is the San Luis Valley in southern Colorado and northernmost New Mexico. And there is the source of the Rio Grande, there in the southwestern Colorado. You can see the snow that feeds the headwaters of this stream. And here we have a scene that in March, and you can see the critical thing of all of this snowpack. That's where the water comes from, for at least the upper Rio Grande. And we're very concerned about what happens to snowfall and snowpacks in the West as global climate change continues. All right, let's talk a little bit about how we measure water, because some of these terms are a little bit confusing. So the easiest way is, of course, cubic kilometers, which is 1 billion cubic meters, okay? But of course, the United States does it differently. We talk about acre feet, and that is the volume of water in an area of 1 acre with a depth of 1 foot. So 1 acre is about 4/10 of a hectare, where hectare is 10,000 square meters. An acre foot is about 325,000 gallons, or 1,233 cubic meters. Just, a lot of words, but give you an idea. Texas reservoirs have a total capacity of 35 million acre feet. The biggest reservoir in Texas, Toledo Bend on the Sabine, holds 4.5 million acre feet. And Lake Louisville here near Dallas holds about 500,000 acre feet. Okay. So here's an acre foot for you. So this is an acre in area, 660 by 66 feet, 1 foot deep. And basically, if you've ever used the swimming pool at UTD, it is 82 feet long, 52 feet wide. But if it isn't 10 feet deep everywhere, but if it was, it would be eight of these swimming pools. Anyway, it's a fair amount of water. All right, let's talk about how we use water. According to the Texas Water Development Board, the average daily use of water for Dallas residents in 2015 was about a cubic meter. 1 cubic meter, 250 gallons per person. The average daily water use for Mexicans in the border community is less than 100 gallons, so much less than the U.S. uses. So let's just think about another little thought experiment. How many Dallas area residents could be supported for how many days by the water of Lake Louisville? So Lake Louisville is northern part of the Dallas-Fort Worth area. And remember, we said that an acre foot, it holds about 550,000 acre feet of water, which is about 678 million cubic meters. Everybody uses 9/10 of a cubic meter per day. So in there, you've got 75 million people days of water. And so if we just say, okay, how many people can that support for 1 year? Then that's about 200,000 people for 1 year. Now, that seems like a lot of people, but keep in mind that the Dallas-Fort Worth area added a little over 1.3 million residents in the last 10 years. So, we could be saying, Houston, we have a water problem. And we just have to be aware of the situation and deal with it and plan for it. All right. Now let's talk about water. Go back to the upper Rio Grande Basin and talk about water. So the condition of the Rio Grande Basin is described by hydrologists as a state of drought, occasionally mitigated by periods of abundance. So on average, less than 2.5 million acre feet are produced by the river's headwaters, which is a little less than the total water held in Lake Texoma on the Texas-Oklahoma border here. The upper Rio Grande produces about 20% of the water in the Rio Grande, and then diversions for water for irrigation claim almost 95% of the average annual flow of the river. And in fact, water right claims exceed the actual supply. And the situation would be even bleaker without the addition of almost 100,000 acre feet into the drainage basin from the San Juan River, which flows over this way, and from another project in the region. So in fact, today, just about 5% of the water produced in the upper Rio Grande Basin reaches as far south as Fort Whitman. So here we are looking at the San Juan Mountains here. We're looking sort of south. You can see the river going through here. This linear thing is the Rio Grande Rift, and that's the San Luis Valley. These are the plains of New Mexico and Colorado, and these are the San Juan Mountains. Ranges, an old volcanic range in southwestern Colorado. Now, the Rio Grande Rift flows south pretty much straight because it's following a geologic feature called the Rio Grande Rift. So it starts up here, and then as soon as it gets into this basin, it just follows it. And you can see all of these lines. Those are basically faults that define the rift in narrow region between mountain ranges on either side. And geophysicists will take gravity measures, and those gravity profiles can be interpreted to show how thick the sediments are in the rift. And basically those sediments are the result of the river flowing south. So as this Rio Grande Rift formed by stretching of the lithosphere by plate tectonic processes over the last 30 million years, that rifting has formed this deep sedimentary basins and channeled the river south as far as El Paso. Now the rift dies out about here, and from this point on, El Paso, Ciudad Juarez, it finds its way to the sea as it can. Now this is a shaded relief map of New Mexico, and so the colors, the darker purples are lower down, and the greens and yellows and reds are higher up. These are mountain ranges up here, and you can see where the river goes. Right, it's easy to follow it. It just goes straight down this rift and ends up in El Paso. So this crust has been thinning to make this rift. Here's the Rio Grande Rift. Underneath it, we can see that the crust, which is normally 40 kilometers thick, has been thinned to maybe 35. And this is what the Rio Grande River flows down the rift of its name. All right, now let's address the question of why is water scarce in the Rio Grande? And the answer is it flows through a desert. Okay, well, why is this region a desert? Well, let's talk about the Hadley cell, the Farrell cell, the 30-degree north zone of atmospheric downwelling, and the thing that these things combine to make the Chihuahuan Desert. All right, so Hadley cells are these big hemispheric circulations. So here we see the equator, and in the equator, the water is heated and rises, and you get all kinds of rainfall. You know, the Amazon rainforest is the direct beneficiary of that upwelling cell of the Hadley cell, and the trade winds that brought the Europeans into this region are another result. El Nino is an expression of what happens to the trade winds and the Hadley cell occasionally. But that rising air over the equator, it rains tremendously. So the air up here is relatively dry. And then at some point, it sinks. And when it sinks, it gets warmer. And warmer air can hold more water than cooler air. So it didn't have much water when it was cool. Now it's sinking, it's warming up, and it's even drier than it was there. And that downwelling limb is a reflection of the fact that this is the northern limb of the Hadley cell and the southern limb of the Farrell cell. Farrell cell is another cell, but it's sort of operating the opposite way. So it's rainy up here up at 60 degrees, and it's dry here at 30 degrees. So the result is that 30 degrees north and south marks regions where you have descending limbs of the Hadley and the Farrell cells, and as they descend, they dry. They are not capable, they don't contain much water vapor, so it doesn't rain. And the Rio Grande flows right through this region. So there's 30 degrees north, and here's the Rio Grande. All right, so here we have a map of global soil moisture from space. And so Orange is very dry. This is basically cubic meters of water per cubic meter of soil, right? If it was, it wouldn't be soil if it was all the way out to 1, because that would be water. But you can get out here where, the soil is more than half moisture. And that's what we're seeing here in the rainforests of the Amazon, Congo, Indonesia. And that's right where that upwelling cell of the Hadley cells are. And then up here at 30 degrees north, that's where the descending limbs are. And with the exception of Florida, which is surrounded by oceans, these are where the desert regions are. 30 degrees north, 30 degrees south. That's where the Rio Grande flows. All right, so let's talk about the Chihuahuan Desert. So here we've got 4 great deserts of North America. The Mojave Desert of California and Arizona, the Great Basin of Nevada and Utah, the Sonoran Desert of Arizona and Northwest Mexico, and the Chihuahuan Desert here, which occupies much of the course of the Rio Grande. So here we've got a map of the Rio Grande, Rio Bravo drainage area. And here is the border between Texas and New Mexico. There's Ciudad Juarez and El Paso. Here's Albuquerque. Here's southern Colorado where the river starts. There's the 30-degree line. All right, so that 30-degree line is really close to where we divide the river into the upper Rio Grande and the lower Rio Grande, the 2 rivers. And basically everything from Fort Quitman to the south, we consider the lower Rio Grande. And this is where this Conchos River Basin becomes very, very important. All right, so here we see sort of a close-up on this region. And this is Texas, New Mexico, Chihuahua, Coahuila, and we can see the Pecos River and the upper Rio Grande, or Rio Bravo del Norte. And we see the Rio Conchos coming in, just about in the area of the Big Bend National Park. This is a spectacular region. These famous canyons cut by the Rio Grande when it had more water are some of the most scenic areas around. Another view of the river from Chihuahua. All right, now the Pecos River flows into the upper Rio Grande. It's the only major tributary of the Rio Grande from the north, and it rises on the western slope of the Sangre de Cristo Mountains of New Mexico. And it's parallel to the Rio Grande. And basically, once you get west of the Pecos, you're in what they call Trans-Pecos, Texas. Now, it's not particularly good water. Gaspar Castaño del Sosa followed the Pecos northward in 1590. He called it the Rio Salado because it was salty. And so nobody wanted to drink it. And the Mexicans, the river was long known as the Rio Puerco, the dirty river. Now let's talk about the lower Rio Grande. So from El Paso to Rio Grande City, the river's entrenched. It's cut a channel and it's flowing through it. But from Rio Grande City to the sea, it meanders, and it has many miles of horseshoe bends where the river does things like this. And before the river was straightened, these channels frequently changed position so that it would create confusion about where the border was. Okay, so we're going to come back to that. So let's talk about the Rio Conchos, which is this river that flows in the Rio Grande from Mexico. So the Rio Conchos is an especially important river system, and it's one of the most important river systems in all of northern Mexico. Now, the river water is coming from the Sierra Madre Occidental, right? There's two big mountain ranges in Mexico, Sierra Grande Occidental, Sierra Grande Oriental. This is headwatered in the Sierra Madre Occidental. And basically, the flow from this river supplies the lower Rio Grande with about 2/3 of its water. Okay, so here we see the Sierra Madre Occidental. It's a high region, and it gets more rain. And this region is a uplifted group of old volcanic rocks, quite different than the Sierra Madre Oriental, which are mostly folded sedimentary rocks. Here's some beautiful scenes in the Sierra Madre Occidental. This is Copper Canyon, and it's a little bit south of where the Rio Conchos are, but you can see it's a much greener, well-watered region than the Chihuahuan Desert to the north. And here you can see the Rio Conchos flowing through the Sierra Madre Occidental. And here we can see the Sierra Madre Occidental, the Rio Conchos drainage basin here in yellow, and then the Rio Grande up here, Rio Bravo up here. So all of this water sort of comes down off the eastern side of the Sierra Madre Oriental and then flows to the Rio Conchos, Rio Bravo, Rio Grande. Another view. Now this one is showing you rainfall. So here we have rainfall in millimeters. So here's 700 millimeters east of here. There's Austin, San Antonio. 600, 500, 400, 250. This is the Chihuahuan Desert, where it's less than 250 millimeters of rain a year. That's less than 10 inches or so. But the Sierra Madre Occidental, look at all of the rain they get. That's 500, 600, 700, 800 millimeters per year. And that's where the headwaters of this drainage is. So now we can ask the question, are Mexicans happy to send water to the United States? And I would think you would have to say, in most cases, no. So there is a dam called Boquilla Dam on the Rio Conchos in Chihuahua. It was built in 1910 to provide hydroelectricity, irrigation, flood control, the usual things that dams are designed to do. And it forms a reservoir with the capacity, something like that of Lake Texoma. And there have been demonstrations there about the water. So in 2020, there was a protest and one demonstrator was killed during a protest by the farmers, right? The farmers want the water too, again, sending water from the dam to the United States as stipulated in the 1944 US-Mexico Water Treaty. So Mexico and the United States disagree on how much Mexico still owes. And there are rumors in Mexico that the United States has overstated its water contribution. So there's a trust issue in there. And previous President Obrador has suggested that the United Nations audit should be conducted. Next. Now, once we get below Rio Grande City, the river changes character entirely. Looks more like the Mississippi with these big loops, right? And these are the kind of meander bends that the Mississippi is famous for. And these are called bancos, or these horseshoe bends. And this figure is a little hard to interpret. This is a false color infrared image where red stands for vegetation. So just in your mind's eye, when you see red in these images, think of green. So one of the things that people are concerned about there are blockages of the flow of the river by water hyacinths. So here you can see the river, it's blue, and here you can see it's completely covered over with red vegetation. Those are water hyacinths. And so, one of the issues in lower Rio Grande is controlling the water hyacinths. Now here's an example of them chopping up the water hyacinths to let the water flow through better. Okay, so now we're going down into this region. We come from Ciudad Juarez, El Paso, down through Big Bend. The Rio Conchos is coming up here. And then you see a few reservoirs right on the river. All right, let's talk about the problems that we're going to have in the 21st century as we try and deal with the water challenges in this, especially the lower part of the basin. So this is a transboundary river, and transboundary rivers are any surface or groundwaters which cross or locate on the boundaries between two or more nations or states. And so when you're trying to figure out who gets the rights to the water in the river, you have to consider not just what's flowing in the river at that point, but also the entire catchment, the entire drainage basin. And the Rio Grande, Rio Bravo is a really outstanding system of a transboundary river system. All right, so transboundary rivers in arid regions, deserts, are especially great challenges to the nations that share these waters. So this is a satellite image of the region. This is the Red Sea here, and that's Sinai, Israel, Saudi Arabia. This is the Nile, and here you're seeing the green, and this is the Sahara Desert on either side of it, and all the people in Egypt live in that narrow strip. The Nile is a fantastic example of the kinds of challenges that are associated with allocating waters of a transboundary river in an arid region. All right. So there's three groups of transboundary rivers in arid regions determined by the water use. So there are situations where the water use is dominated by the upstream nations. So maybe the Colorado River of the Western United States would be one example, or the upper Rio Grande. That basically the upper part of the river, the nation that lies in controls it. And then there are other examples where the downstream nation dominates the use of the water. The Nile is a great example of that. Egypt is the dominant user of the Nile, and the Jordan River is another one. Israel in particular uses more of that water of the Jordan River. And then there are some where the nations, the riparian nations, are equal partners. So the lower Rio Grande and the Niger River in Africa and the Tigris-Euphrates River in Iraq and Turkey, those are examples of equal partner riparian nations. All right, so what we've got is a mechanism for resolving disputes between the United States and Mexico. It's called the International Boundary and Water Commission, and it was established in 1889, and its modern functions were established by the 1944 treaty. And there's a U.S. section under the U.S. State Department and a Mexican section under the Mexican Secretariat of Foreign Relations. The U.S. section headquarters is in El Paso, and it's responsible for applying boundary and water treaties between the U.S. and Mexico and for settling differences, with a focus on the Rio Grande, Rio Bravo, and the Colorado rivers. And in fact, the IBWC is recognized as a model of effective cooperation for dealing with transboundary water. So, some of the accomplishments of the IBWC. So they settled the Chamizal dispute with the signing of a treaty in 1963. This treaty got the two nations to agree to channelize the river through a concrete channel that prevents it from changing course, and which, when it changes course, then you have all sorts of confusion about where the boundary is. Then they agreed to construct two dams, the Falcon and the Amistad, in 1953 and 1969. There's an agreement for a third reservoir, but that hasn't happened. And then, as a result of settling of the Chamizal dispute, they got rid of these bancos. And so by 1970, the Boundary Commission had sliced through 241 of these to straighten the river. And basically, when you do that, you have to figure out, okay, whose land is this on, that used to be on the south side of the river or the north side of the river, now is on the opposite side. And so they basically agreed that those bancos that protruded into Mexico went to Mexico. The ones that were protruded into Texas went to Texas, and more than 30,000 acres of land changed hands as a result. All right, now the IBWC field offices and jurisdictions. So, you know, here's the Upper Rio Grande field office. There's one in Presidio. There's one at the Amistad Dam, one at Laredo, one at the Falcon, and then one in the Lower Rio Grande, and then other ones in there as well. All right, so let's talk about the reservoir. So there's two of them we want to talk about. One is this is Amistad up here, and the other one is Falcon down here, right on the Rio Grande. So Amistad and Falcon are considered to be one system with, there's water that's frequently released from the upstream dam to replenish the Falcon reservoir and meet the demands in lower Rio Grande Valley. The IBWC operates these reservoirs to supply water and control floods. And the United States and Mexico separately own water stored in the two reservoirs. So here we've got a map of what it looks like. Amistad Reservoir in Texas and Coahuila. And it's the second largest lake in Texas when it's full. And then Falcon is downstream. And it is a little bit shorter dam, but built in 1953. So here we've got satellite image of the Amistad Reservoir. The dam is here, right? The Rio Grande is coming in here and then flowing out here. There's the town of Del Rio. And here's the Falcon Reservoir. So Mexico and the U.S. settled the water debt in October of 2020, and Mexico reached the deal to pay its shortfall from the border area. And the deal basically transfers Mexico's share of the water in the Amistad to U.S. ownership. And basically, you know, 170 million cubic yards or 130 cubic meters, about 20% of Lake Louisville's worth of water. All right, now things have gotten complicated because of this border wall. So this is the border wall that have been awarded and using different kinds of funding, Department of Homeland, Department of Defense. You can see there, you know, big sections that have been committed along California, Arizona, New Mexico. But you can see that the Rio Grande is a much more difficult place to build the wall. You know, that is really striking how that big of a gap is. And obviously there's issues, many issues around the border wall. But with a river, you've got a different situation than you have when you're just out in the desert. So what are the challenges in the lower Rio Grande Valley? So there's 5 of them. There's rapid population growth. There's already 20 million people that live in the area, and it's growing fast. Extensive industrialization. And because of NAFTA and USMC, the maquiladora industry is growing. That's bringing in more people. There's serious pollution problems related to population growth and the industrialization, and that can leak into the underground water resources. With groundwater depletion, you get salinization, you get salinity problems, and in many cases the water salinity is too high. And then, of course, aquifer depletion. Groundwater pumping is depleting the groundwater. So those are the problems we have today, but we need to prepare for the future. So, you know, inhabitants of the Rio Grande Valley, and especially the lower Rio Grande Valley, have had to face water shortages many times in the past. And because of the growing population and economic growth, these are going to increase the demand for water while its supply has become less. And with climate change, we don't know how much less it's going to become in the future. What do we need to do to prepare for the future? So another complication, SpaceX. So we talked about Brownsville as where the trouble started between the United States and Mexico 170 years ago. Well, something else is happening in Brownsville now, and that is SpaceX. Brownsville is not a very big city, 100, maybe 200,000 people, but this is where SpaceX has its launch facility. So basically, it's well situated because you can launch east, and you're not going to rain debris on anybody until you get over by Miami, by Florida or Cuba. And this is growing fast. This Elon Musk space company now has more than 1,600 employees at this Boca Chica site, where it's building the Super Heavy rocket and the Starship spacecraft. Today, SpaceX is already Brownsville's largest private employer. It first started testing rocket engines and flights in 2019, and this is after starting to buy up properties down here in as early as 2012 and unveiling this site as its launch site in 2014. So this is transforming this aspect of the lower Rio Grande Valley into a really high-tech center. All right, so we've got to make some adjustments. And how do we do this? So anyway, these are the things that might be helpful. Number one, we need to conserve existing resources. The water conservation could be achieved by discouraging first-year crops, by appropriate water pricing, and by metering and charging for water use. We need to have a plan for sustainable economic development. What is the best use of the scarce water in the border region? Agriculture, or factories and cities? And then probably we need to amend the 1906 and 1944 treaties. Those treaties were for a different time, and they were written to deal with the needs of a small and largely agricultural population. If the region is going to develop further, then these agreements need to reflect the challenges facing a large and increasingly industrialized economy and urban population. And most importantly, we need to find more water. And how can we do that? Well, there's ways to do it. It's possible to build an aqueduct system that would divert water from water-rich regions to the north and east in the United States. So, for example, eastern Texas, Louisiana, Oklahoma, and Mexico, maybe regions to the south, and transport this to the Rio Grande. And so with a larger supply of water, this region would be in a much better situation to develop its agricultural and manufacturing industry and support a larger population. So as an example of this, let's look at the California Water Project. So California, and especially Los Angeles in the early 1900s, started taking water from the Colorado River and basically takes all of it. But in the 1960s, the state realized, okay, that's not enough water for the growth that's going to happen in Los Angeles. So they came up with a plan to build dams to provide water from the water-rich north and ship it south on an aqueduct all the way down. And this project involved 21 dams and 700 miles of canals. But the estimated economic benefit is about $400 billion annually. It basically allowed Southern California to grow and become the powerhouse that it is. Couldn't we do the same thing? I mean, why couldn't we build an aqueduct from either the Arkansas Canadian River in Oklahoma to the upper Rio Grande, or from the Mississippi? They got plenty of water. Or from the Sabine River, or maybe something from elsewhere in the Sierra Madre, and bring it into the region. Something like that is possible if people move strongly and the political will is there. But with climate change, we can't count on Mother Nature to provide the water that we're going to need for this region. So thank you, and the next lecture will be on the last part of Latin America we haven't talked much about, which are the Antilles, the region around the northern and eastern rim of the Caribbean.